Hello, and welcome to another episode of Hacking with Friends. My name is Kody Kinsey. I am a security researcher with Varonis, and this is my friend Michael, our junior senior executive production gremlin. Now today, we're going to be talking about microcontrollers again, but not the ESP8266. Today, we're actually going to be talking about the ESP32, which is the successor to the ESP8266 and is much more powerful, but also has some restrictions built in. Michael, what do you know about the ESP32?
So it's very, very popular for IoT products. It's a Wi-Fi micro chip that, so basically it was an IC designed for Wi-Fi, and then makers discovered that, oh, hey, there's enough processing power on here between Wi-Fi cycles to actually do like useful stuff. So then it became very popular for a bunch of IoT and maker products because they discovered they could have Wi-Fi and a microcontroller all from like one little module.
Yeah, so really the game changer here is processing power.
Yeah.
Now the ESP8266 is a great little microcontroller. We do our Wi-Fi hacking stuff with it because it's able to send completely unrestricted Wi-Fi packets, which makes it very useful as a lightweight and easy to program Wi-Fi attack tool. We can also use it as a reactive Wi-Fi target and for all sorts of other stuff, but where it falls short would be something like a video application where maybe it's taking video from a camera, encoding it, and then sending it over Wi-Fi. It just wouldn't have enough power to do that in any sort of appreciable quality. So what we're going to look at today is a step up from that was basically designed for Internet of Things applications that are a bit more demanding than the ESP8266 can handle. And a really, really popular application for the ESP32 is cameras.
Yeah, like this.
Like this one right here.
Spooky little spy cam.
Yeah, so we have a couple different ESP32 form factors that we're going to look at today. We have just the bare board, and this is a very small, very compact, and easy to work with ESP32 module that I like because it's, just very, very tiny, and it will generally fit with other ESP8266 accessories. However, it is a nightmare to solder because it has lots and lots and lots of pins, and they are right next to each other, so you have to be creative about making sure you don't short this thing out. Now, this is a great form factor to work with if you're looking to get into working with Bluetooth as well. Now, the ESP8266 has Wi-Fi, but it doesn't have Bluetooth. And it turns out Wi-Fi and Bluetooth actually operate on the same frequency. So the
2.4.
Yep, on 2.4 gigahertz. So the ESP32 has a little bit more power, a little bit more ability to load more of the stacks. And if you've ever tried to load up the Wi-Fi and Bluetooth stack onto a microcontroller, you'll notice that it is huge and takes up a ton of space. So my suspicion is that while the ESP8266 might technically be capable of doing Bluetooth if you really pushed it, it probably couldn't then do Wi-Fi. And in this case, the microcontroller is really, really pushing itself to be able to provide both interfaces, which is really cool if you have like a smartwatch or something else that you want to be able to interface with, or if you want to explore Bluetooth Low Energy, which is an incredibly low power application of Bluetooth that allows you to connect devices that consume basically no power, where maybe you have a little coin cell battery that would last for like a year or two.
I know that's a problem with a lot of these like ESP-based products, is if you're trying to do battery powered, Wi-Fi is not a great solution unless you know that it's just going to last like an hour or two or a couple hours.
Right. So one question we get a lot is, if ESP32s are so great, why do we use the ESP8266 at all? Well, as I mentioned before, the ESP8266, the lightweight version of this, I guess, was a lot more simple when it came out. The SDK for it was able to be manipulated to do all this interesting stuff in a way that makes it, I guess, less locked down than this tool is. So the ESP32 is massively more complicated than the ESP8266, and as a result, it's taking the community a lot more time to unlock its full potential. So while this is actually technically probably capable of doing the stuff that the ESP8266 can do, it is a lot more difficult to get it to do those things. So you'll find that this is going to take a while before some of the same innovations that have percolated into the ESP8266 community are actually able to be ported to the ESP32.
Yeah, I was going to say that. 82 has just been out longer. And also, like, does the 32 do 5 gigahertz, or does it still only do 2.4?
It's only 2.4 gigahertz.
Okay.
So that's another restriction on this. It's only 2.4 gigahertz. It doesn't do 5 gigahertz. So if you're looking to do some 5 gigahertz hacking, then unfortunately this isn't it.
Yeah.
Now, there is another tremendous disadvantage, in my opinion, to the ESP32, and this goes back to a GitHub forum that I've been trolling persistently on and off for about a year now, every time I get angry. And there is somebody who's refusing to implement analog write for the ESP32. So if you are using Arduino to do projects and you like to use analog write, go to this GitHub forum and complain to them, because I've been trying to get them to implement such a simple function to allow you to write code for both microcontrollers for a year now, and they won't listen to me.
For those of us that may not be massive nerds, what exactly does analog write mean?
So one of the great things about this is that it has so many pins and interfaces that you can rig it up with lights, sensors, anything you really want. And these sorts of components that you can add to a microcontroller like this are typically either analog or digital. So when you're controlling them, if you have, say, a sensor that's giving you an analog temperature, it's not a precise reading, it's somewhere in between, then we need to be able to either read or write or otherwise work with analog values. And it's just a massive important thing to have when developing microcontrollers. And for whatever reason, the person who is in charge of that has not committed anything to fix that problem. So this has been going on for over a year. I believe this is issue number 3 that was raised about this microcontroller in Arduino. So just keep in mind that while this is a great development kit, it's also, if you're an Arduino developer, a little frustrating sometimes to find that Espressif hasn't fully committed to making sure this is interoperable with other code for example, the ESP3266. So a little bit of a frustration there, but in spite of all that, there's other form factors that we like much better. So here we have an ESP32 cam. And this has been out for a while. It has a disadvantage in that you need to connect to it with basically like a serial connection here. So we have a little adapter that lets us connect directly to the pins and then use a micro USB adapter. But this is a really, really awesome camera that you can get online for about $5. And what's nice about this is it actually enables you to do facial recognition and some other really interesting applications on this, which again, for $5, being able to do facial recognition is pretty cool. So the more I guess, dressy version of this is the M5 stack camera. M5 stack makes a lot of really cool hardware around the ESP32, and I find that this has pretty decent interoperability with Arduino. So if you're looking for something that's a little fancier, then the M5 stack camera is a little more expensive, but the hardware is really good. You just need to be really careful to make sure you get the right one, depending on what you want to do. So for example, this one was a bit more expensive, and it's able to do facial recognition because it has something called PSRAM. Michael, can you show yours?
Oh,
yeah.
This one.
Yeah, so this looks like the Terminator with its skin off, but this is a USB Type-C, which is pretty cool. Really cheap. I think we got this for like $5 or $6.
Yeah, all of these are like $5 to $10 range.
Yeah, and this says it's from M5 Stack. It's from AliExpress, so who knows where it's actually from. But it doesn't have PSRAM. So the advantage is USB Type-C, $5. Like, that's really cool. And it can do streaming video. And in fact, it streams pretty good quality video when you get it set up.
A good quality, but very low frame rate, which can be an issue sometimes.
Yeah, I found that this one's still pretty decent.
Yeah.
Like, depending if your
depending
Wi-Fi
on
speed
the use
is,
case.
Yeah, depending on your use case, and depending on your Wi-Fi speed as well, it's a pretty decent camera for how small and how cheap it is. But it will not do facial recognition because this model does not have PSRAM. So PSRAM is a type of RAM that allows the camera to do other things. Let's take that back. That allows the camera to do other things besides just, streaming video or something. You'll notice that when we test this out, at a certain point, the feed will get much slower because instead of focusing on sending us all the available frames, it's going to be processing them, looking for faces, and then trying to identify them. So pretty cool. Again, you can't do some of the things you could do with the previous generation, which is de-authing and some of the other great stuff. But there is a lot of potential here, and there's going to be even more as the community continues to unlock this.
Well, and it's not like you'd be able to do those simultaneously either. It's not like you'd be able to take an ESP32 camera, be streaming video and de-authing stuff at the same time.
Oh yeah, you
could you?
Yeah, you could. You just need to schedule it. There's not really true multi-threading, but you can do something where you're scheduling different things to be happening. For example, an attack that we have on the ESP8266, which is much less capable, has us creating an access point and also kicking people off other access points at the same time.
Gotcha.
So because Wi-Fi does have some tolerances built in, you can get away with doing some stuff. So imagine a security camera that if it recognizes a certain person, it
just
de-auths.
them?
Just de-auths any new device in the area. So you're just not that guy. Anybody can join my Wi-Fi, but not that guy. and he wouldn't know why he can't join all of a sudden. He'd have the
Targeted
password.
harassment.
Exactly.
You would never do that.
Yeah, well, really what this allows us to do is write programs or do other things that are based on people's faces or other identifying factors. And you can use the same kind of technique to do things like recognizing license plates or having other applications where you would want a small, durable camera that's lightweight and really has a good amount of power behind it considering the incredibly low price. And also the ability to work with Arduino is a really, really big advantage here. So we're going to get into some of these. We'll hopefully drop some links. If you have questions about which ones to buy or which ones are cool to work with or which can do what, please ask us, because we are trying to explain how these great tools can be used today, but it can be a little confusing because if you pick up, the reason I have so many of them is I kept ordering the wrong one for the application I needed. So I wanted to do facial recognition and I got a whole bunch of the one that Michael has, only to find out that it does perfectly good streaming video. So we were actually able to connect to it and then do facial recognition on our end. So it was just feeding us video frames and we were doing facial recognition on it. Cool. But we were actually able to do onboard facial recognition with this one because it does have the PSRAM in order to make that happen on the chip itself. So that's really cool. It means that we don't need to have a program on our end doing the facial recognition. This can actually take care of it itself. But there are applications where you can just get a cheaper version of this that doesn't have the PSRAM and then just connect it to like a Python program that's doing face recognition. All right, so let's go ahead and go to my camera my screen.
Your screen?
Yeah. And I want to show off just some of the really cool projects that are out there for this if you decide that you're interested. So I found a couple projects I liked, but real-time facial recognition with the ESP32 camera, I love this guy, is a really compelling reason for using this sort of thing. It gives you a lot of flexibility for creating your own applications that depend on someone's face. And if you go to the GitHub repository that is by M5 Stack, you can see that they have a really good description of the different cameras they have. The ESP32 camera is the one that Michael has. I believe I have the M5 camera A, maybe? Or either the M5 camera A or the M5 camera B. And you can see like the stats. There's different ways of compiling firmware for it as well, which I am not going to go into because it is hard and annoying. But here's a kind of breakdown of the RAM, whether or not it has flash, if so, how much. Really, really cool for if you want a quick cheat sheet for a particular application that you're trying to do. Now, some of these also list that they have batteries or the ability to add a battery. On the bottom of this, there's a little connector for a battery. So if you wanted to make this more autonomous, maybe connect it to like a solar power system and make it really like able to just like, be persistently out there, all of this is possible, which I think is really cool. I guess I could just look at the back. This is an ESP... Yep, okay. So I have an ESP camera B. Yeah.
What's the difference?
It looks like...
Is it just like a newer revision?
Well, it says here, if I really want to dig into it.
Yeah, it's not that.
Yeah. Yeah, this one versus this one. This one says it has 4 megabytes flash, 4 megabytes PSRAM, and then it's a 2 megapixel camera. So I'm not sure if maybe this other one has a different resolution of camera.
And so what's the importance of the PSRAM is for doing processes
onboard processing, yeah. So anything that you want to do that involves processing means that you need to have PSRAM in order. Okay. Oh yeah, this one. These basically have identical stats. I barely understand what's different in them. But I believe it has some like variability with like the things you can connect, how many pins are exposed, the Grove interface, like all that stuff. So.
Oh yeah, I think that's what this is. That's the Grove interface, not a power battery.
Well, yeah, but you can also use it.
Can you?
Yeah. Yeah. So yeah, it really depends on what you want here. There's a bunch of different examples for how to actually, like use one of these. But we're going to show off today how to get started. And I also wanted to shout out this other project. We couldn't get it to completely work, but I've seen it working in the past. Stefan, who works exclusively, well, not exclusive, but extensively on the ESP8266, has ported a number of his projects over to the ESP32. And one of them that's cool is the ability to sniff packets. So what's interesting about that is you can use this as a little packet sniffer, maybe a proximity monitor where if someone's within a certain range, it would be able to tell. And that's a really interesting application for this as well. So I'm going to see if I have Arduino open. Yes, I do. And I'm going to go through the procedure of basically setting this up so we can see what it looks like. And then we're going to switch over to Michael's screen, and we're going to get him set up in just basically getting the ESP32. So when you have Arduino IDE, there's generally a number of example sketches that come with every board you install. So when you install the ESP32, which if I go into Arduino, Preferences, there's the additional board manager URL. This is where you drop all the boards that you want to work with. And in my case, I'm sure...
You got a couple there.
Yeah, I have a couple. But right here, I have the package for the ESP32 right there. What that does is it allows me to search for the board, and I can go into Tools, and then Board, and Boards Manager, and I'm able to type in ESP32 once it finishes downloading the platforms index. And what that'll do is make sure I have the latest version of the ESP32 board, which comes with all these handy example sketches. So here you can see I have the latest version, and this is what you want to have installed if you're working with these boards.
Yeah.
All right.
Yeah, I had to do this before we got started.
So then if we go to Tools, we should now see under Boards a bunch of different groups of boards, and the ESP32 Arduino is what we're looking for. And from here, we can go through and we can identify the one that we're looking for. So if I want to get started with this, you might notice that right now, I don't have the M5 stack board I specifically have. We have the M5 Stick C, the M5 Stack Fire, the M5 Stack Core ESP32. I can select this, but then if I go into examples, I might prove myself wrong. I actually haven't tested this, but let's see.
And so what are these board managers doing? Just when I type pin 0, it knows to go to this certain pin or something like that? Or...
Yeah, so it's downloading example sketches and board firmware for each one. So if you're flashing something, it'll basically be able to set everything up properly so it's mapped to the correct pins and that the sketch is consistent for that board.
Gotcha.
So I'm going to go into examples once I've selected the board I'm interested in. And then I can see there's a whole bunch of stuff. ESP-ROM, ESP32. And here, oh, well, maybe it is here. Let's see. We can see there's an ESP32 camera, which is a camera web server. Wow, there's actually a lot of stuff. There's an ESP32 Azure IoT Arduino.
Because, that's exactly what you want to do with your camera, connect it to the cloud platforms.
EFAT, that's for formatting and FAT. NetBIOS, SD ESP32. Wow, there's so much stuff here. It's great. So we have web server, different web server examples you can do, advanced web servers, hello server. I just love this stuff because if you don't know what you're doing, you can just get up here and start picking different sketches that will already work and just upload them, see what they do, see if they're useful.
Yeah, I think for me, when I was first approaching this, one of the most intimidating things going into Arduino is you're like, oh my god, I don't know Arduino, I don't know how to code, I don't know how to program all this stuff. But then discovering, hey, a lot of times you don't even have to do that. And if you do, you can often find something very similar and just modify it slightly.
What? I didn't know you could connect to a router using WPS. I'm going to build a brute forcer with this. Okay, cool. Well, anyway, so yeah.
Future live stream.
Yeah, so you can discover all sorts of cool stuff with that. In this case, I can open the ESP32 web camera server. So that's what we're going to focus on today. I'm going to get rid of this other sketch. No, I don't want to save it. Okay, so this is our example sketch. And the first thing that you'll notice is that this sketch works across a number of different platforms. So if we want to do the AI Thinker one, then we can use that, which is basically the cheap $5 one that has the PSRAM. If we want to do that, this will work. We can use, whoa, oh my god,
it's running away.
Yeah. We can use the one that Michael's using, so that's the one without PSRAM. Or which would disable certain features, or we can use the ESPi. I believe that's oh no, the ESPi is.
Yeah, this one's not really labeled.
So the ESPi is the official board from Espressif that has it has a microphone on it. I wish I'd found it. I can see it in its drawer, and I should have gotten it before the stream. But the official ESPi is the Espressif board that allows you to do voice commands, because that's important. But they're in Chinese, so the first command you're supposed to say to turn it on and get it to do stuff is a Chinese word that's hard for English people to say. So it's really cool, and they put a lot of thought into it. But also why? Couldn't it? Whatever.
Yeah.
So in this case, if we want to
Flash custom firmware with English.
Yeah. So in this case, I can select the camera model M5 stack PSRAM, and I'm not sure if it's going to work or not. But the way that we select a particular model is I comment out the one I don't want anymore, and let's see if we can uncomment the M. Oh, that's Velcro.
Oh yeah, sorry.
Comment out the M5 stack PSRAM. All right, so I'm going to go to Tools, and currently this is already working, so I very well am probably just messing it up, but we'll fix it. I'm going to select the USB to UART, which is the correct interface, I believe. Oh, let me unplug the other one just so it doesn't get confused.
Yeah, so with some of these cameras, you need that extra board to program them, like the programmer, and then others have that included, correct? Or
okay, so that's a confusing statement. So for all of these boards, you can connect with them via whatever interface they provide and program them.
Okay.
However, for this one, if you don't want to have like an intermediary device because it just has pins to program and you have to program it basically over serial, we bought these handy like USB to serial interfaces.
Yeah, that's why
you don't necessarily need these. You can still program this over an FTDI programmer or something like that. But yes, like this one doesn't have a USB interface. So if you don't have any way to interface with FTDI or just with the pins, then you will need something as an intermediary. But there's lots of different options.
This one, you don't need any of that. You just plug it into your computer.
Right, because that one has a serial to USB programmer.
Right, and that's
in the
what
chip
I was
actually on the board. Yeah. So all right, I've eliminated the wrong one. That should be this one then. Let's see if I can upload, and we'll see it compiling the sketch. Oh no, I didn't. Okay, well, I forgot something. So we also need to give it an access point to connect to, or how will we see it?
You mean our network isn't star? And
yeah,
star?
It turns out it's not all stars. Who knew? So let me make sure that my
our network's not an all-star.
I have no response to that. Yeah, all right. So okay, so we have an error. Let's see. Sketch too big. Text selection exceeds available space on board. Okay, cool.
But this is like the default sketch, right?
Yeah, so that just means we need to change it. So that just means there's something like some definition isn't lining up. Let's try the M5 stack wide. Don't know what that is. Don't know why it would work.
There's this big warning on line 5 and 6.
Well, I mean, the overall warning was that it was too big.
Yeah. No. I mean, up here it says, make sure that you have selected either ESP32 Grover module or another board which has PSRAM enabled. Yeah. Okay.
This one has PSRAM enabled. Okay. Oh, it still says it's too big. Okay, cool. So that's an interesting error. And I think this was the one I was using before. So that... Oh, you mean this warning?
Yeah, that's what I was saying.
Yeah, that's fine. So here, if we want, we can see it's suggesting we have the ESP32 Rover model or another with PSRAM. If we go down to Tools, Board, so it looks like this board isn't working out for us. So let's try to find another one that actually might allow us to do this, because I don't know what the ESP core is, but obviously it doesn't like this. So let's do, let's go ahead and do the AI Tinker one.
There's a lot of boards there. Is there an easy way to search through them?
It's already been upgraded. This is actually better than it used to be.
What?
I know, right?
Oh dear God.
Yeah. Okay. So now we've selected the AI Thinker model. That one should have roughly everything where it needs to be. Let's see if we can compile this. And we're telling it that in spite of having selected that board, it's actually the M5 stack wide. So it should set the pins correctly if we select this right. And you guys will probably get some errors like this if you first try it out. There's some really good guides on getting this set up, which I'm not following deliberately today. But I think Random Nerd Tutorials does some really good ones. And I think also 4 Data Science has some decent ones on the ESP32 as well. All right, look at that. It's uploading. It passed the test. Through this random smattering of different...
Just click on random boards until one of them works.
Yep, there you go. So there's also some guides. I feel like I'm like prescribing like off-label medication. I'm like, well, this is like for a totally different board, but it'll probably work for you too. You should try it. So we'll see how effectively this is managed to like translate over.
Then you try to plug something in and the pin's like, oh, nope, you just connected power.
Well, the next error will be that it fails to find like an acceptable camera when it probes for it. So if we get that one, then we'll work through it too. But overall, we're in business. We're transferring data over USB Type-C to a microcontroller. That's pretty cool. Let's go ahead and then press Command Shift M, and that should give us the serial monitor. And it looks like not only was it able to successfully find the camera, it was also able to start a web server after connecting to the Wi-Fi network. So what happened here? We created a Wi-Fi network on my phone. We gave that information to the microcontroller, and then it was able to start up, connect to my phone's Wi-Fi network, and then begin streaming video over that network.
So, point of order about security, you just put your password in plain text in that program. So, like, if I were leaving these cameras somewhere or something like that, could someone easily just grab the device, plug it in, and steal that password from it?
Yeah, I mean, if you wanted to dump the binary and like see the program that was written there, you'd probably be able to find the Wi-Fi password.
Because I've heard of similar things happening like that with like old Wi-Fi light bulbs that used to do that, where they would just like, you could grab a Wi-Fi light bulb from the trash and connect to the ESP in it and just dump the password in it.
Yeah, that's probably not that hard because these, they're not encrypted or anything. They're not trying to make it like too sneaky.
Yeah, so just something to keep in mind if you're gonna lay these around everywhere. Maybe you want them on another network or something. So I am in
Chrome, which I hate, and now I will go to Firefox. Whoops. Okay, well, we'll blur that, I guess. And then here we go for this.
More work.
Yep. All right, so we have here a bunch of different controls, and that's great, but we also have a black box. There's nothing here, and I'm going to disable my my blocker here so it'll enable everything. So initially the resolution quality is pretty diverse. I'm going to pick the best one, of course. I'm going to turn this back towards us, and then I'm going to click on Start Stream. Look at that. It's Michael.
Oh, yeah, this is the slow frame rate, though, that I was mentioning. Is you can tell it's like 6 or 7 frames per second.
Yeah, so, I mean, not the fastest.
You're not going to be recording, like, Muhammad Ali or, like, any kind of sport or athletics with this.
Right. Okay, so let me go ahead and try to turn on face detection. Guess what happens? It doesn't work. So we're going to have to go through and reduce.
That's a lot of toggles over there.
Right, so we've reduced the quality. Hey, look at that. Now I'm a ghost, for one thing.
What is it? Why is it ghosting like that?
Because it's cool. But
is it a ghost in the
my
shell?
God. Okay, well, that's sweet. It looks like there's a skull coming out of our wall. All right, whatever. But this allows us to do facial detection. So let's try to turn it on now. Oh, look, it's detecting a face. What a huge surprise. You'll also notice it is much slower. So the reason it's much slower is because it's detecting a face. It's doing processing actually on the microcontroller, which is pretty cool. The question, of course, is whether it can tell the difference between Michael and me. And can it do it reliably? So let me turn on recognition.
Intruder!
Yeah, and it says there's an intruder. It does not recognize me. So you can also see it's gotten very slow. And if we want to try maybe a different format.
Yeah, even lower resolution.
Here's a different format. Intruder alert, intruder alert. Yeah, so these are all pretty low resolution, but go ahead and hold this.
Sure.
If I go back to Arduino, try not to show off too much of our studio. Look at that, detected, detected, detected. So let me take this. So I'm going to point it down, and then I'm going to point it up. Detected, no match found. Detected, detected.
We're down to 1 frame per second sometimes.
Yeah, when it's processing a facial match, it will do that. So I'm going to turn it down again. So you can basically see when people are here by when it's detecting a face.
So it'll give you an alert. So that could be useful for like home automation stuff and whatnot.
Yep, exactly. So you can see that it's taking MJPEGs. It's then comparing them anytime it's face alias not found, face alias not found, face not aliased. Cool. So this means that we can write a program that is able to just detect when faces are there. But let's go. So that's facial detection. But let's talk about facial recognition. So, all right, here we are.
Wait, so isn't it doing recognition if it's saying intruder alert?
Right, but it's not recognizing against a database of anything. It's just saying, this is a face I don't recognize, but it will always say that because no faces have been enrolled.
Gotcha.
All right, so let's enroll a face. I'm going to position this so you can see most of my face, hopefully. Yes, I am an intruder. I'm going to click on Enroll Face right here, and it's going to take a series of frames. I'm going to try to move my face a little bit to get some more robustness. So you can see it took a bunch of ID samples. So I turn my head to the left, I turn my head to the right, and now it's able to identify me.
Mm-hmm.
So let me turn this down again. I am now subject 0. So I'm going to go down, I'm going to go up. Lagging a little bit. There we go.
There.
So I'm not an intruder. So
Yeah.
over in Arduino, I go down, I go up, match face 0. All right,
That's
so
pretty
now,
nice.
yeah, so now let's go over to Michael.
Is there a practical limit to how many?
Who knows?
Intruder.
So we see that Michael is an intruder. So Michael, try to get your whole face. Okay, so let's go ahead and enroll Michael. A little higher. A little higher.
Yeah, it's the lag.
Okay, good. Just like that. So as soon as we start enrolling, I want you to turn your face from the left, from like the left, straight, and then right, and then try to look up and down. Ready? Go. All right, ID sample 1, ID sample 2, ID sample 3, ID sample 4. Okay, that's pretty good. All right, so now you're subject 1. So let's see if it can do. So go ahead and lean in. We're going to be out of our boxes, but go ahead and lean in. Subject 1.
Apparently, I'm more important.
Okay, and subject 0.
Yeah,
All right.
I think it can only do one at a time.
No, it can do multiple ones. All right, so here we can see that it's identifying. Oh no, it thinks I'm an intruder. No, it's back to thinking I'm okay. So there's some things that can easily confuse the facial recognition on this.
I was gonna say, apparently it's not liking the lighting on our set. It seems to be blowing out the image.
Oh no, it's fine. It would be worse if it were darker. So this is pretty typical for these sorts of microcontrollers that are doing facial recognition on the actual chip. So there's a lot of stuff I can do that would confuse this. One of them would be darkening my eyes.
So question here. Would it be
They can't detect me. Sorry.
Would it be possible to just stream like the raw data from the camera to another computer somewhere and actually like let that computer do all the processing?
Yeah, like I said, that's what we did. So for our Hack 5 video, we had your camera that you're holding right now just streaming to a Python program that's running locally. So, this sort of facial recognition is definitely limited in some ways. But, if you want to just do a high resolution version and just pipe it over to a Python program, which with much higher processing power, then, this is a good wireless camera that you can just get started with.
Right.
So I want to share some other ways that we can defeat facial recognition. Michael, I'm taking your mouse. We can also, in some cases, just take a dark object and put it somewhere near where it's expecting to see skin tone. And provided that it's like a cheek or something that's expected to be light, that can defeat recognition as well as detection. Now, one thing that I think is extra stupid is these microcontrollers. You can see it's detecting my face. What if I do this?
Yeah, that's the one I think stupidest. Like, the fact that this even works on certain cameras.
Yeah, so I'm tilting my face to the side and it can't detect me because now I'm completely hidden in camouflage. Okay, well, fine, make your point, Mike.
Can you imagine someone getting through a security somewhere just because they like walked with their head tilted the entire time?
Yeah, so cheap microcontrollers that do facial detection and recognition do a really bad job of detecting tilted faces. As soon as I bring my face back up, you can see it has no problem detecting me. So a couple tips for that sort of thing. If you want to confuse facial recognition, then that is a pretty good way of doing it. Just tilting your head if it's a cheap version. And then also, I'm gonna just take this. If you just hide certain parts of your face, also, it can make it really difficult
like
to
the bridge of your nose,
the bridge of your nose. Like suddenly my cyborg implant has rendered me unrecognizable. It doesn't know who I am anymore. It doesn't have enough data to make the calculation. So we've been messing with these for a while and just like playing with them to see if we can break them. And you'll notice that like, while I am getting some positive identifications, it's really struggling with it, and it's not as accurate or successful as it was before.
Yeah, like my favorite one is just like wearing a glove and then you just have a really, really itchy nose or eye or something, and you're just like, dig it in,
Yeah, so For models that use eigenfaces, that's pretty good. For other models that don't use light and dark and use just mappings on the face, there's usually 2 layers. There's just first the recognition and then the detection. So it kind of depends on like which model you're trying to break. But for, yeah, let's see. I don't think I really have anything too dark here. Oh, no, wait. I have a glove, a dark glove.
Oh yeah, that's literally the same glove
Yeah, it's the
I
same
used
glove
in
you
my
used.
Hack 5 video.
Yeah, so
Just
for,
a little dirtier this time.
You know, I don't want to bring it too close to my face, but you know, something just darkening up part of the face. I don't know, Michael, this isn't working so great.
See, no, it's
It still knows who I am.
Here.
All right,
Since
let's
you're
see it.
too weak to wear a little glove that's got a little dirt on it.
I'm sorry, guys. Look at how filthy this glove is.
Oh yeah. Okay.
It knows exactly who you are.
Why? This is blasphemy. See, no, an intruder.
All right, buddy. All right. So as you can see, there's some pretty cool applications for what this can do. And let me actually kick it back into high resolution mode just so you guys can see the difference. Whoa. So obviously a huge difference between the low resolution mode and the high resolution mode. You can also adjust the quality. This is obviously much worse, but we're streaming at a much faster rate. So depending on what your application is, this could be a pretty good match if you just want something that's relatively cheap, easy to work with, has great documentation. Yeah, I would say it works pretty well.
Yeah, like I feel like this sort of thing's great if you want to know like who stole the cookie from the cookie jar, or do like a doorbell that recognizes your nosy neighbor, so you don't have to go to the door. But for any other like application, like I feel like it's just a budget option, right? Like,
exactly.
what is this?
I don't. Some sort of malfunction. Whoa. Okay. All right. So let's go ahead and switch away from this now. I think that's all we're gonna do with the ESP32 today. But in general, I would say that this microcontroller might not be the Wi-Fi offensive tool that the ESP8266 is, but if you're getting started with Wi-Fi applications and you want to be able to add just a camera or something a little bit more powerful, there are some really cool projects out there. I know that one of our friends makes the Wi-Fi, the ESP32 Wi-Fi Marauder, which is basically like a signals intelligence type device that uses the ESP32 to scan for other devices, detect them, and kind of do some really interesting things there. But you should look out in the future, because as security researchers play with this microcontroller more, as they begin to learn how to hack it better, you might see some of these really cool features unlocked in the future and be able to actually use the considerable power behind the ESP32 to maybe pop up some really convincing phishing pages, or do some of the other stuff that we're currently doing on the 8266.
Before we get too far down the ending rabbit hole, I know earlier you mentioned that you could even use stuff like this for recognizing license plates. Yeah. And I was going to show this real quick. Like, so like there's open PR, so open source license plate recognition software and stuff available. And you mentioned Random Nerd Tutorials. They have a whole bunch of these project guides. If you're interested in maybe following one of them, we highly recommend checking out some of their videos and articles. Or if you want us to do a live stream and just like walk through the entire process on one of those live streams, let us know in the comments and we can definitely do that. There's a ton more projects you can do with these. On like the home automation side, I've seen people like make video doorbells out of these for like $5. So that's really nice. Even using them inside, so like if their kids need to come in their office or something, they can let them in, or other applications like that. So a lot of potential uses with these.
That being said, I do not recommend doing any sort of access control projects with these, just because, as we saw, they can really fudge identification sometimes if people have similar facial features, or if you have a picture of the person that lives there. You can hold up your phone and probably be able to
I know that was a big thing with the first generation of facial recognition on smartphones, is you could just look up the person's Facebook profile and then show a picture. And that's why a lot of those systems eventually switched to 3D facial recognition, because then it's a lot harder. Then you have to print like a 3D mask of the person's face, which is a little more challenging. Usually.
Yeah, actually, let's go back to my screen. Now I want to try it. Sorry, before we
No,
close out,
no.
we're
Oh,
gonna
okay,
try.
Fine.
All right, so let me turn back on facial detection and recognition, and let's see if we can spoof the system a little bit. So, Michael, I think that every time we turn this on and off, it like resets. So, oh no, wait, it still knows me as subject 0. So I'm gonna go ahead and just create a digital Michael. I'm Michael. Let me in. Let me into the house.
Intruder.
Okay, thanks to the intruder. You do have your eyes closed in this picture.
Yeah.
Why it is quite bright in Arizona. I need a picture of you with your eyes open. Oh, here we go. Okay, cool. Perhaps this one. All right, so we're gonna go ahead and try spoofing again. Come on, I'm Michael. Let me in. Believe me.
The camera's like, nope, I froze.
Oh no! Did I unplug it? That would be tragic.
No, I mean it looks plugged in.
Yeah. Oh, maybe I just need to stop stream, start stream. Ooh, it hates it. It hates it.
Yeah.
Oh well.
Whatever. That's another thing to keep in mind if you are gonna play around with these. You know, they're not always the most polished
Reliable?
of products. Yeah.
Yeah, that's definitely true.
So.
In fact, it knocked itself off the network.
Oh no.
Yeah.
A deal itself.
Oh no,
The
I
plot
think
thickens.
I think it. Okay, now there's two. Now there's 2 devices connected, so it should be back now. And yeah, it's back. Okay, cool. So I'm gonna set this to SIF, whatever that is. Facial detection, facial recognition, start. All right, we're up and running again.
Okay.
Do you know me, machine? Have you forgotten me, your closest friend? No, I am merely an intruder to you. All right. So here we're going to do a picture of Michael.
Hey, at least it detects face.
Yeah, it detects the face. So let's go ahead and enroll you.
Oh, wait. Yeah. We're going to enroll me based on the camera image.
Oh my gosh, I can't even see what is going on. All right, so did it enroll? Who knows? Yeah, okay, there we go. That was stupid.
Hello, subject 0.
All right, so now you're subject 0. Then if I bring you back live, we're kind of reverse engineering this. Whoa, you're an intruder. What? Wow, okay. All right, I take back part of what I said. It might not be as simple
Well,
to
I'm very
use.
washed out around.
Yeah. It might not be as simple to use a picture of someone as I thought, but I have gotten this to work before. So just beware if you're using this for like access control or something, then you may not.
Yeah, we're not doing the
do
best demonstration right now, but
No, it's okay.
I do know that these work like that.
Yeah, I just think it's really funny that you can use pictures to mess with these devices because yeah, it's not taking any depth imagery. It's not taking anything related to whether or not this is a flat picture or it's being projected or whatever. It's really, really simple to spoof these. So these are really cool devices, but they're not necessarily up to par for the kind of security you would want without some sort of second factor.
Yeah. And well, just a curious side note, I think even if this were using like 3D facial recognition, like there's this thing called photogrammetry. It's recreating 3D images from video or images. So you could use that and then like use a 3D printer and a video of the person to 3D print their face.
That's
and
horrible.
Then compromise the system.
Terrible.
Yeah.
Terrible. All right, so hopefully you guys have seen some of the interesting applications that are available for the ESP32. It, just like the ESP8266, is a super cheap, readily available, and easy to get started with microcontroller that you can use for a variety of different projects. So if you've been meaning to do a video-based project, or if you just want to explore some of what this microcontroller is capable of, we highly recommend M5 Stack products. They're really great. We also highly recommend this $5 ESP8266 ESP32 cam, which you'll find everywhere.
And if you're going to buy a bunch of them, AliExpress, best place if you're willing to wait a month.
Or 2.
Or 2, depending on how shipping is with the virus going on. But if you need them sooner, spend a couple extra dollars and get them on Amazon. Like, save yourself a bunch of hassle.
Exactly. Yeah, and you can find these things all over the place. So a lot of these things will work really well. Just make sure you pay attention to the ones that do and do not have PSRAM if you're interested in facial recognition.
Cool.
Cool. All right, so as always, we have a big shout out to Varonis for making this series possible. If you like this and you want to check out some other free Varonis resources, make sure to check out the PowerShell AD course, where you'll learn to do a lot of powerful scripting using PowerShell for Active Directory.
Powerful PowerShell.
Powerful PowerShell. All right.
Indeed.
So that's all we have for this episode. If you guys have any ideas for future episodes, make sure to shout them out in the comments. We love answering your guys' questions, and we will see you next time.